A trolley is accelerated by a constant pulling force, which means I'll get a constant acceleration. A tape attached to the trolley is pulled through a ticker timer with a frequency of 50 hertz. That means the period of that ticker timer is 1 over 50, and that turns out to be 0.02 seconds. The dots are made by the tape of the ticker timer. The table below gives the distance measured on the tape in 3 consecutive time intervals of 10 dots each, which is 10 spaces each. I mean, we start with our first dot, and then the dots keep coming until we've got 10, and then we stop, and that's interval 1. Then we do it again, and interval 2, and interval 3, which means that each interval is actually 10 times the length of time of one space or one dot. So how long does each interval take? 0.02 times 10. Calculate the acceleration of the trolley. Now, the way that you calculate acceleration is working out a velocity for the first interval and a velocity for the second interval, the last interval, realizing that they're both at the halfway mark, and then working out a change in velocity. So let's go ahead with that. You're going to say 0.36 divided by 0.2. That's the time taken. So that turns out to be 1.8 meters per second. Where is that true? It's really true at a half for all intents and purposes. Then I can say 0.48 divided by 1 interval space is 0.2, and that turns out to be equal to 2.4. And where's that true? At 2.5. So this spot here is 1.8, this spot here is 2.4. When I'm working out acceleration, acceleration is going to be equal to change in velocity, 2.4 minus 1.8, divided by the time. And the time is half an interval, a full interval, and half an interval. So it's 2 intervals, 2 times 0.2. That is the length of time for an interval. And my answer will turn out to be 1.5 meters per second squared. Then it says the trolley's mass is 2 kilograms, frictional force is 1.5 newtons, so determine the magnitude of the pulling force. So here we've got this trolley. It's being pulled, that is the applied force. It's obviously got friction working against it, 1.5, and that's your frictional force, and it's 2 kilograms. So we know force resultant is equal to big force, applied force, minus little force, 1.5. But force resultant is 2 times the acceleration, and that's applied force minus 1.5. And therefore the applied force, which is what they were asking me for, is going to be equal to 4.5 newtons in the direction of motion. And finally, calculate the speed at the end of the third interval. All right, that's a little bit more tricky perhaps. We're going to need equations of motion. So I am going to say I have an initial velocity. I have some time periods along there. I have an acceleration value. So I'm going to try v is equal to u plus at. The final velocity is what I'm interested in. The initial velocity is 1.8. The acceleration is 1.5. And the time is, they want it at the end of this third interval. So it's a full interval, another full interval, and half an interval. So it's 2.5 intervals. And how long does an interval take? 0.2 seconds. And when I do that, I find that I get an answer of 2.55 meters per second. This question is not very clear, I apologize, but really what they want you to do is find the frictional force. That's going to be this dissector, at least this point over here. If you were just answering, you might have said 5, you might have said 4, you might have said 6, but in terms of what was given in the quiz, 6 newtons was the correct answer. Frictional force is where it crosses the y-axis. What is the mass of the object? Mass is equal to force divided by acceleration, or change in force over change in acceleration. So it's change in y over change in x. I'm going to go with 27 minus 20 over 6 minus 4. That's my 1 point, that's my other point. And again, there would have been a margin for error if you were doing this not on a quiz, but in this particular case, this came out as your answer. And you get an answer of 3,5 kilograms. Here we've got a tape. We're asked to determine the velocity from A to B. Velocity is equal to change in displacement over change in time. I need to change this into meters. So it's 0,005 meters divided by a time period of, they've told me the frequency of this ticker time is 10 hertz, so it's 1 over 10, which is 0,1 seconds. It's only one space, 0,1 seconds, and I get 0,05. And where's that true? At A.5. Sorry, this is meters per second. The next question, determine the velocity from E to F. The velocity from E to F is going to be 0,025 meters divided by the time for one space, 0,1 seconds, and I get 0,25 meters per second. And where's that true? At E.5. So I've got A.5 and E.5. Now I need to get the acceleration. Final velocity minus initial velocity divided by the time. How many time spaces are there? 1, 2, 3 and a half, so it's a total of 4 spaces. So it's 4 times 0,1, which turns out to be 0,5 meters per second squared. In this tape, we are asked to get the velocity from A to C. So I'm going to say velocity is change in displacement, 30 millimeters, 0,03 meters, divided by the time, and the time is 2 spaces, so it's 2 times 0,1. And that turns out to be 0,15 meters per second. Where's that true? It's true at the midpoint, which is at B. Remember, it's the midpoint of time, and B is the midpoint of time. The final velocity is going to be between D and F, so I want that whole area over there, so it's 0,09, 90 millimeters, divided by 1,000. Again, there are 2 spaces, and I land up with an answer of 0,45 meters per second. And where's that true? At the midpoint in terms of time, at E. Finally, if I'm going to get acceleration, final velocity minus initial velocity divided by the time. How many time periods are there? 1, 2, 3 time periods, and therefore it's 3 times 0,1, and my answer is 1 meter per second squared. What is the frictional force of the surface along which this object goes? Frictional force is where it cuts the y-axis, so it's 0,05 newtons. And what is the mass of the object being dragged? Again, mass is equal to force over acceleration. Good news, that's change in y over change in x, so I can just get the gradient. Choosing any 2 points, and of course again there was a margin for error here. I went, I think, along with that. And the answers were a bit variable, I must be honest, so there's a few different points that you could choose. You need to change, I'm going to go with this change in y is 0,3 minus 0,2, and the change in x, we're going to go 0,4 minus 0,25. It's not quite 0,3. My answer is 0,66 kilograms, and given the multiple choice options that were available, that was fairly close to the answer.